Let's do a little screencast on promises, callbacks, async awaits, waterfalls, race, parallel, all these things for JavaScript beginners. So let's do this. So promises. So what is a promise? Just like a regular promise that you might make to your parents, to your family, to somebody else, to a friend, to your kids. So for example, you might say, hey, I promise to get you an ice cream. Now in the coding world, that would translate to, I promise to get you database results, I promise to get you the REST API results, I promise to get you this config information, I promise to do my assignment, I promise to tell you after 20 seconds have passed. Now in the case of if you promise someone to tell after 20 seconds have passed, more time may have passed, but you know, you're going to promise them that you're going to tell them after 20 seconds. I promise to write information to logs. So these are all different kinds of promises you can make when writing code as well. So, you know, promise me that you will learn about promises. Now, a promise is also just a promise. So if somebody said to you, I promise that I'll get you an ice cream. Well, that's just a promise to get an ice cream, right? Or if somebody said, I promise to get you the database results. Well, that's also just a promise. So if you just kept promising about promises, those are all just promises. So that's something to understand, right? And so next, callbacks. So callbacks are essentially things you would do when a task was fulfilled, or in other words, a promise was completed. So you might say something like, call me back to play when you get the ice cream, or call me back once you get the database results. So these were like callback functions, which were something happens and then you make the callback function. Now you could chain these callback functions and say, okay, you know, when you get the database results, then make this callback, but then that callback says, okay, now go log this, and then that other callback says, okay, now go set up this other thing. So you can keep nesting these callbacks, and that can become very confusing and messy, and that's called a callback hell. Don't use callback hell. So if you were chaining callbacks, that you might as well chain promises instead of chaining callbacks. So chaining promises is instead going to look like do this, then do this, then do this, then do this. And that's a lot cleaner than nesting a bunch of functions one inside another. So don't use callbacks, use promises instead. Okay, so now how do you use promises? Well, you can write promises the old way, where you say, you basically create a new promise object. And the way you create a new promise object is you pass in a callback of what the promise does when the promise is either resolved or rejected or broken. So, for example, your dad's promises to bring you ice cream, and he doesn't bring you ice cream because he had to work overtime. So the promise gets rejected in that case, and if it gets resolved, he maybe brought you the ice cream. So the old way is to create this new promise object with a resolve and a reject of what happens if the promise is fulfilled, what happens if the promise is broken. The new way is to use an async function. An async function's return value is always the promise. And if you want to reject things, you simply throw errors. So if Dad stayed over work time, you throw a new error saying Dad stayed at work overtime. And if the promise is going to be able to resolve, eventually you're just going to return the ice cream. So how do you write async functions? You just have async get ice cream, get DB results, async user account config, anything like that. And in the code, I've actually written it in arrow function syntax. So we're just saying const add promise equals an async function, and that function returns an ice cream. So now let us talk about await. So we have async, which basically returns promises. And what do we do with those promises? Well, we wait for those promises to happen, and then we do something. So the old way was again to use a callback within a then function. So you would say dad's promise, and then we get the ice cream, we eat the ice cream. If we catch an error, then we debug the error. Say failed to get an ice cream. Why? Maybe, our error was dad stayed overtime at work. The new way, instead of doing this callback, because we're just throwing errors and returning from the function, is to use the await keyword. And so we wait for dad's promise to be fulfilled, and we then put that in the ice cream. If we catch an error, we debug it. So much simpler, no callback hell is possible because we're not nesting functions. It's just a simple try-catch block. Whereas in the old way, as you can see, if we, again, inside the then function, we started sticking in more promises and so on, we can start to quickly have a callback hell. Now you could do then multiple times, just like you have then and then catch here. So async functions, so you could use making the promise the old way and then reading it using an await the new way. So you can mix and match here. Because basically an async function just returns a promise, and an await simply waits on a promise. The only thing is that the await functions can only be used from within async functions. So you can await any of the promises we created, like getting user accounts, database results, configs, writing logs, any of those things. Now async, whatever I return is always a promise, like I told you. So for example, let's say that we do const get ice cream, async, return ice cream. So what are you going to get back? Are you going to get back the ice cream? No. You're going to get back a promise that you will get back the ice cream. Okay? So that's important. A lot of people don't get this part right, where they see the return value and they think they got the ice cream. They didn't. You see the async keyword? So that means that this function is returning a promise. It's returning a promise to return the ice cream. So what about the second one? It's also returning a promise. So remember what I told you, a promise of a promise is just a promise. And so either way, if you returned a promise to get the ice cream or you return the ice cream, the async function is returning a promise to get the ice cream. So if you're returning a new promise, here you are using the old syntax of resolve reject, and maybe you're waiting on this other function called ice cream delivery. You're waiting for ice cream to be delivered. If there's an error, you're going to reject that promise. If there is a result, you're going to unbox the ice cream from the box that's delivered to you and take out the ice cream and then resolve with that ice cream. So either way, both of these ways will resolve with the ice cream. But you see the second one quickly looks messy because we are returning a new promise instead of using our new async await syntax. So what can we do? So one thing we can do is we can abstract out this ice cream delivery function into its own ice cream delivery async function. And in that, we're just going to return the new promise the same way, but we're not going to do any post-processing. We're just going to resolve directly with the result, and we're going to reject with the error. And then our actual getting the ice cream function becomes much simpler. So we're going to do const delivery, await ice cream delivery async. So we're going to wait for the delivery, and then const ice cream, delivery.unbox.takeout ice cream, and return the ice cream. And so remember, this async function will return the promise. So if you're going to want to eat this ice cream, you're not yet getting the ice cream, you're getting a promise, because you're going to wait on the delivery and then unbox it and take it out and then return it. That's the promise, that you're going to do all that. So if you remember that async functions always return a promise, promises can be broken. So if you notice here, I did not catch whether the ice cream delivery async function is broken. But that's because I'm going to catch on the get ice cream. Could I get the ice cream or not eventually? So if there's an error that got thrown inside, then here you can see when I try to eat the ice cream, that's when I have it inside a try-catch block. So I'm going to try, to get the ice cream, and I'm going to eat the ice cream, and then I'm going to catch the error and debug why I failed to get and eat the ice cream if there was an error. And that error could come from the delivery process, or that error could come from me trying to unbox it. And let's see, what did I do in the function above? Delivery, await ice cream. So I think that's just the same function, yeah, okay. So we're waiting for the delivery, we're unboxing it, returning the ice cream, and then we're eating the ice cream. So notice that get ice cream does not return the ice cream, it returns a promise. And we have to wait for it in the eat ice cream function. Okay, so now await can only be inside async functions, like I said, right? Otherwise, you got to go old school or refactor your code. So if you, for example, have a synchronous function, eat ice cream, which has a whole bunch of other synchronous stuff and a bunch more other synchronous stuff or whatever it is, and perhaps that you want to keep it synchronous. So we'll talk about why you may want to keep it synchronous. So in that case, you're going to say get ice cream and then use the old syntax of passing in the callback for ice cream, eat ice cream part, and catching any errors and debugging them. So why would you want to do this? For example, let's say you have an existing callback hill and you have all sorts of callbacks and nested synchronous functions, and you need to go add some logs. And your logging is asynchronous. So that logging could be like getting and eating this ice cream. Now this doesn't mean you want to necessarily go and refactor your entire code base and keep bubbling up the async everywhere. You can if you want, but that might be very time consuming because you're just trying to log something perhaps. And in that case, you would just have to take your async logging and use the old .then syntax to do the logging, or in this case, eat the ice cream, and move on. So that's why you still want to know the old syntax, because you may need it in case you don't want to refactor an entire project at times. Now, Waterfall. So what's going on with this? These come from async libraries from the days when AsyncAwait was not a thing, and you had all this nested callbacks, and all of the callbacks eventually came down to calling one final callback. And so that's what waterfalls are. We no longer need all this falling down callback functions. We can simply use AsyncAwait, create a bunch of async functions and put them all in one AsyncAwait function, and we just await this, await this, await this, await this, await this, and then finally return something or do something with it. That's your final thing. So you can completely remove waterfalls using AsyncAwait. Same thing with race using from the async library. So race was like just launch a bunch of things and then have them race. Well, that's already what async functions are. You just create a bunch of async functions and run them, and they will race each other. So you don't really need to use race from async either. And same thing with parallel. So what parallel used to do was it would run a bunch of functions in parallel, and then when they would all finish, then it would make some sort of a final callback. Well, you don't need to do that anymore. You can basically just create a bunch of async functions which return promises, or create promises like in this example where there's a new promise being created. Notice an actual return value like 42 or a number or any object can also be considered a promise by promise.all. So then you just use promise.all. Promise.all will wait for all the promises in the array to finish, and then you just define the callback function that you have for finishing all of those promises. And so this way you can use parallel, you don't have to use parallel, and you can just use promise.all, and you can get away from all the callback hill that comes associated with parallel. And finally, a note on libraries, right? So a lot of times corporations will have libraries where there's a lot of different buildup within the libraries for corporate checks and different things. If you're forced to use those, and they're using some sort of older callback-based syntaxes, you can basically wrap them into some sort of a library function of your own and then use async await there. So you basically will define an async function which returns a new promise. It resolves with the things from these older libraries or rejects from the things from these older libraries. And that async function, as you know, always returns a promise, and then you can use it in the normal async await fashion from there. And if you're not stuck with having to use an older corporate library for some reason, and you are free to use any modern library to do your work, then you may want to use libraries which are newer, which support promises and async await functions. And basically, the library just has to return a promise when you call it, and then you can use awaits on it within your async await functions. So instead of event handlers requiring callbacks, you can use libraries like superagent or Axios in case of like HTTP calls, for example. And not just HTTP calls, like you can use more modern libraries with async awaits for all the different things that you might need to do, such as databases, logging, HTTP requests. And well, if you're writing a library, you know what to do. Don't use callbacks and use async await instead. So finally, let me show you one example where we will have async without and call it without await. So for example, in a web page, you are making a call to a backend, and if you remember the old days, we used to use jQuery Ajax, and now it's much better with like this libraries. So you can use something like superagent or Axios, like I said, and you simply can define your async function, try, and you can get your await, make the HTTP call, get the response, log the response, catch any errors. Remember, if you're making promises, they can fail, so you always got to try and catch around awaits. You're waiting on a promise. What if it fails? That's why you got to catch it. Now, if you're catching it in an outer function, that's fine. You don't need to catch it over and over in all the inner functions. You can just catch it, once and for all outside if that's what you want to do. But if you have a lot of catching to do, you have a lot of async awaits, you may want to catch different specific errors within the functions as well. And so here you can see this async function is in a file of its own where it's not, we don't have to wait on this async function, it's just going to do its thing and then log some things. And so we can wrap it inside our parentheses and use the two parentheses to make a generic call to this function and then let it do its thing and then log to console. So here's an example of calling an async function without needing an await, although there's an await inside the async function, as you can see. So if you have the outermost level of an async function, you can call it this way, where nobody else depends on it or needs to wait on it. And so that's all for my quick little presentation on async await. So we've gone over promises, callbacks, async, await, waterfalls, racing, parallel. We've gone over library functions and also how to use the async function at the outer level without an await. Now you should understand what promises are. You should understand promises are just promises. You should understand that callbacks should be stopped as much as possible. And you should understand that asyncs always return a promise. Awaits always resolve the promises and throw errors on rejection, and that's what you have to catch in try-catch blocks. And async, whatever it returns is going to be a promise, whether it's a value or some promise. So, and promises are meant to be broken, so be sure to catch once again. And awaits can only be used inside async function. So if you see an await that's not going to be inside an async function, your compiler will throw errors. So if you need to do if you have a lot of callback, like synchronous ones, one nested inside each other, and you need to do something, you may need to use the old school .then.catch syntax. And don't use waterfalls, don't use race, don't use parallel, and that's it. So I hope you enjoyed my little presentation on async await promises, callbacks, waterfalls, all these things. See you next time.